Welcome to video clip 2.6, in which we discuss intermediate events. So intermediate events, as already discussed in the previous video clip, happen after the start of a business process and before its termination. Intermediate events can be both catching and throwing, not at the same time, but they can be intermediate events with a catching nature and intermediate events with a throwing nature. Catching means the process waits for the occurrence of the event, and throwing means the process emits the event and continues with the outgoing sequence flow. And an intermediate event can be connected to other nodes of a process model by incoming and outgoing sequence flow arcs, just like activities or other nodes of process models. Looking at the application scenario and expanding a little bit on the application scenario, if the order is placed on a Friday or on a weekend, the inventory check shall be delayed until Monday, as the inventory is updated every Sunday evening. So here we have another constraint that we did not represent so far in the process model. So let's try to do that using an intermediate timer event. So intermediate timer events can only be catching. And that is exactly what we need here. And these intermediate timer events act as a delay mechanism. And we can specify that by using a date time, for instance, December 16th, 2013, or by a recurring date time, for instance, every Sunday or every Saturday at 10 a.m., or by duration, for instance, when we say they're 1 week. In the example, we have the following, and here we have the process model that is related to the textual representation of the scenario we had before. So there is a decision, so whether the order date is between Friday and Sunday, so if the product has been ordered on a weekend, then the upper branch is chosen, and in the upper branch we don't have any activity, we just have an intermediate timer event. And the timer event does nothing but waits for the event to occur, for the specified event to occur. So at that point, let's say on Friday afternoon, the order is submitted, and then the process instance goes through this to the upper branch. And then this is called Monday at midnight, Monday at 0 o'clock, so to speak. And so the process waits Friday, the Saturday, the Sunday, and on Monday morning at midnight, so to speak, then the event fires and the process continues. And the process continues, and then we can check inventory availability. So intermediate timer events act as a delay mechanism in processes, and this is a typical example of how this could be used. Timer events do not need to be embedded in the sequence flow of a process, but they can also be boundary events. So a boundary event is, as the name indicates, on the boundary of an activity. And boundary events are always catching events. And the occurrence of a boundary event is only relevant if it occurs while the activity is in the running state. So let's draw a little process diagram with a boundary event. So here we have process continues, activity A. Then we have an activity called B. And the activity B has this intermediate event, and it's a boundary event because it is, drawing is not very nice, but this is a boundary event, and there we continue with activity C, and here we continue with activity D, for instance. And that needs to be, the sequence flow needs to be a bit longer. It should go until B. All right. So here we have an activity B. The activity B has a boundary event, an intermediate event that is exactly on the boundary of this activity. And the occurrence of the boundary event is only relevant if it occurs while the activity is in the running state. So this the occurrence of this activity, that can for instance be a timer event, is only relevant if it occurs while B happens. If it occurs before B starts or if it occurs after B has terminated, it does not have any meaning. It's not relevant. It's just the event is only relevant if it occurs while B runs. There are two variants of boundary events, which are interrupting boundary events and non-interrupting boundary events. Interrupting boundary events interrupt the activity. So once this intermediate or this boundary event occurs, B is stopped. B is interrupted, not continue to the end. Non-interrupting boundary events, this is not the case. So B just continues normally, and of course C is triggered as well. We see that in other examples as well. So expanding our application scenario a bit further, if the product is not in stock and an error occurred during manufacturing the product, the order shall be cancelled and the obtained materials be disposed of. In that case, the process terminates unsuccessfully. So we represent this situation or this requirement of the business process as an interrupting boundary error event. All right, so how does that work? When the boundary event occurs, manufactured product is interrupted and the flow continues with cancelling the order. So looking at the process model, we talk about this area. So this activity manufactured product has a boundary event. It's an error boundary event. So if within this manufactured product event an error occurs, then the order is cancelled. So then this exception flow is then called, is executed, the order is cancelled, the material is disposed of, and we have the end event that indicates the cancelling of the order. If this error event does not occur while manufactured product is performed, then we just use the outgoing sequence flow, confirm the shipping, and the process continues as specified here. Okay, typically events or activities to handle the error situation are started after a boundary error event occurred. So these are typical error handling activities that are executed after a boundary error event has occurred. So the question is, what is the difference to an XOR split decision? Couldn't I just use an XOR split to say if an error occurs, then I go that way, if no error occurs, I go the other way? And in order to discuss this with you, I would like to use another little example that looks rather similar to the one we had before. So we start with an activity A. We then have an activity B. With this boundary error event. So then I have here the C, activity C, that continues somehow. And here we have the situation in which the normal process behavior continues. And well, I could just represent this as an XOR split decision. So here we have the activity A, then we have activity B, and then we decide whether we go to C or we go to D. And then, of course, the process continues at this. So what's the difference between these two alternatives? Well, I see quite some differences, and probably you also see the differences at this point already. So the first difference is that the execution behavior is different, because in the upper example, using the boundary event, the activity activity B is interrupted, is cancelled when this event occurs. In the lower part, using the XOR split, that's not the case. B terminates just perfectly, just normally, and then there is a decision about whether to use C, the error handling, or whether to use D. So it is a decision that is based on conditions that are attached to the sequence flow edges, as we know. But in the upper part, the decision is not taken by a condition, it's not specified by a condition, but by an occurring event, by an error event. So also from the modeling perspective, it's quite a different thing. If I model it as I did in the lower part, I just say, well, there is activities A and B, and then there is a decision. Either I go for C or I go for D. But if I use the boundary event, it's clear that the normal flow is A, B, D. So if nothing bad happens, it's A, B, D. However, if there is an error, oh, I need to go the C way, and I need to make error handling and so forth. So also from the modeling perspective, it's a difference to indicate that there is if an error occurs, then I need to do activity C here. All right, so there are subtle differences. The decision is based on event occurrence on the one hand and by conditions on the other. But there's also a difference in execution semantics, since in the XOR case, the activity completes, so activity B in our case, while it does not in the case of the boundary event. And also, as we indicated from the modeling perspective, it's clearer that an error has occurred rather than a normal decision during a business process. And here, in that case, I think also that this decision is, or it's modeled, the situation is modeled appropriately using the boundary error event, since if an error occurs during manufacturing the product, I don't need to continue manufacturing, I just cancel the order and get rid of the material. If the error does not occur, then a manufactured product continues properly, terminates, and then the normal flow of the process continues. I would not be able to express the same semantics using the XOR split. We also talked about non-interrupting boundary events. Well, boundary events might therefore also be non-interrupting. In this case, the activity continues just normally while spawning a reaction to the event. And the notation is a bit different. It's a circle with a dashed double border. So interrupting events have the normal double border, and non-interrupting boundary events have the dashed double border. Here's an example also related to our scenario. So I like to inform the customer if manufacturing takes longer than expected, but of course I do not want to interrupt manufacturing in this case. Here we have, using the highlighter, I use the non-interrupting boundary event that is attached to the manufacture product activity here in the process. And I have a timer event. I could specify a certain, it's not further specified, that depends on the goal of the process and of what the customer expects, of course, so it's not further detailed, the particular timing behavior. But if the timer occurs, so if it takes longer, maybe if it takes longer than 2 days, for instance, then the boundary event occurs. The inform customer about delay activity is executed, and then the process, the strand stops here. Other than that, if the manufactured product completes before the timer is fired, then the timer has no effect. That's also a nice example of a situation where the timer does not have any effect. If the product is manufactured maybe after 1 day already and the timer is planned for 2 days, then of course the occurrence of this timer does not have any effect on the process anymore. Okay. So couldn't we specify the non-interrupting event as an end split? Isn't that something like an end split that we use? And what in particular is the difference to the end split? Also in this case, there are subtle differences. And also I'd like to sketch that. Maybe I can get rid of the solution at this point in time. Assume we have an activity B. An activity B has now this non-interrupting event. And here we have an activity C, for instance. And we have an activity D in the normal case, and that's embedded in the whole process flow. Why not doing something like this? So we have activity B. Then we have the end split of C and of D. And the question is, so what is the difference again here? Well, first of all, not in all cases C is executed. So that's the first difference. So the modeling as an end split would not be correct, since C does not need to be executed if B is, or if the boundary event does not occur while B is active. And also, it's not clear from the modeling perspective that that's an additional activity, C is an additional activity that is only executed if the boundary event actually occurs. So also there are quite some differences in the semantics of this. I need to use the eraser because I have the subtle differences as well, or specified here in this part of the slide. So there's a difference in the execution semantics, since in the end case activities are sequential, while this is not the case with the boundary event. And we need to be careful with joining the flow in an end gateway, since the event can occur several times. So also this boundary event can occur really several times. So it can, depending on the occurrence of the event, then I can send several notices to the customer that the product is late, and also that would cause problems when we again wanted to join the different nodes in an end join. All right, we come to intermediate signal events. So signal events are specific, or have a specific property, and the property is the scope of the signal event. The scope of the signal event is not a single process instant in its environment, but it can be used to communicate the occurrence of events among different business processes. And that's different from what we've seen in the other events, also the other intermediate events, that the scope is always the business process itself, and signal events can be used to address a broader scope, to also, let's say, have implications on other business processes. Okay, so how does a signal event look like? Very simple example, so activity A. Then we have a signal event. Signal events are triangles that, if throwing, are black inside, and then we have the B. And so that's a throwing event, and that means after A has occurred, a signal is thrown, and then B has occurred, and this signal can then be caught by a number of other business processes. Could also be many other different business processes. So a BPMN signal, and this is from the specification, a BPMN signal is similar to a signal flare that shot into the air, into the sky, is visible to everyone who might be interested. So that's the way in BPMN to communicate events between different business processes. We also have an example of an intermediate signal event. So a signal event may be used to inform another process to replenish the inventory if a product is currently not available. And so we have here this intermediate signal event that throws, let's say, the event in the air or in the sky, and that is caught by this replenish inventory intermediate process. If the process is just at that position, it could also be a start event of another business process. That would also be possible. And once this event occurs, this replenish inventory event occurs, then of course the upper process can continue, can check the inventory, can do back orders and things like this. So this is the way signals are the way in BPMN to communicate events across different business processes. There's a very nice BPMN poster that is produced by the BPM-Offensive Berliner BPM-Offensive. So that's just a snippet of the poster, though that's a complete poster that you also can order at bpmb.de, and there are posters available in a variety of different languages. Hopefully your language is also supported, is also available there. And so this is the part where the events are characterized. So this poster is reasonably complete, and this just shows you that there are many events, or event types, event kinds available in BPMN. We just discussed some of them. So let's see which were the ones we discussed. The untyped events we took a look at. We looked at message events, we looked at timer events, also intermediate timer events. We also looked at error events. So we captured quite some of them, but actually not all of them were discussed in the context of this course. That brings us to the end of video clip 2.6, where we took a look at intermediate events. Intermediate events can be catching. In this case, they act as a delay mechanism. They can be throwing. In this case, they just throw the event and the process continues, so no delay if an intermediate event throws. Boundary events restrict the scope of an event occurrence to an activity. So boundary events are attached to the boundary of activities, and they only react if the event occurs while the activity is running. Boundary events can be of interrupting and of non-interrupting nature. We discussed the relationship of boundary events with XOR and with AND gateways. And finally, we discussed signal events, and we took a look also at the events, complete set of events as specified in the standard and as present in the BPMN poster. This short video summarizes what we looked at in the second week of the course. So we took a look at activities in BPMN. We discussed that they represent units of work, that they take time to be completed. Activity instances contribute to a process instance. We've seen that process models can have many process instances. Process instances contain activity instances, and activity instances behave according to a state transition diagram, where they first are in the init state, then they are normally in the ready state, in the running state, in the terminated state. However, we've also seen when it comes to splitting behavior, then certain activity might not be required, so we can change state from init to skipped also. We looked at task types that determine the nature of a task that can be used to enrich business process models with a type of task. The second part, we looked at gateways, especially the exclusive OR gateway that can be used for exclusive choices. So I can have 1 out of M. So if exclusive OR split has M outgoing edges, then I can choose exactly 1 using this. We looked at the execution semantics of the XOR split, and also we looked at the default flow that is required. We can use the XOR gateway also to realize looping behavior, and then the loop condition is basically the condition of the outgoing edge of the XOR split. We looked at the AND gateway that allows interleaved ordering of activities, but also concurrency. So when certain parts of processes can be executed independently from each other, it's a good idea to use the AND gateway for these parts. The OR gateway offers quite a flexible behavior, because the OR split would trigger any subset of the follow-up activities using the sequence flow or conditional sequence flow attached. So we can have n out of m, so any n out of m is allowed here, so inclusive choices. We discussed the OR join, which is quite easy to handle in the context of structured models, but in arbitrarily structured models, it's still challenging to calculate or to implement this behavior of the OR join. We discussed uncontrolled flow, and also we discussed that you might be careful with using uncontrolled flow, because the split and join behavior is different in uncontrolled flow. Finally, we looked at events, in particular start events and end events. Process models should have 1 start event. Process models should have 1 end event for each possible outcome of the process. So these end events need to be exclusive to each other. We looked at intermediate events that might be throwing or catching. And finally, we looked at boundary events that might be interrupting or also non-interrupting.